Hello everybody, Sir Leon here and welcome back to another mathematics video. In this video we will be looking at rotation and let's head straight into it. So it says rotation refers to a transformation that turns a geometric figure about a fixed point called the center of rotation. Now this transformation involves rotating each point of the figure by a certain angle around the center of rotation. And like all of the other transformation, the requirements for rotation would be the center of enlargement, the angle of rotation, and the direction. And this direction will either be clockwise or anti-clockwise. So let's look at a simple example of how a rotation will occur about a point. Now, in every shape, if you want to rotate a shape, now this rotation must happen about each point. Each point must be rotated in order for the entire shape to be rotated. So for example, let's say we had this point P. We wanted to rotate this point about the origin at a certain degrees in an anti-clockwise direction. So what we do, so the point P is here. So we take a line and we draw a line, we take from the point P and we draw a line straight towards the origin, which would be this line here. And then we measure the amount of degrees that we want anti-clockwise. So we know clockwise is how the clock will read, and anti-clockwise will be in the opposite direction. So in this case, it's anti-clockwise, so we'll go into that direction. So based on the amount of degrees you want, when you open your protractor, you mark off that degrees and you draw this line out. And then you take your compass and you connect these two lines, and that will give you how the point rotates about the origin anti-clockwise. So let's say we wanted to rotate the point P about the origin at a certain degrees clockwise. So we draw a line from P, the same steps, we draw a line from P to the center of rotation, which would be the origin. We take our protractor and we measure the amount of degrees that we want. And then when we see that degree, mark it off, and then we extend our line through that number of degrees. Then of course we take our compass and we open our compass and we open it from the point, from the center of rotation to the point P, and we just scribe an arc to give us where the intersection will happen. And at that intersection, that will be the rotation of the certain amount of degrees. And that's how you perform a rotation. We'll look at that a bit more further down the video. So now let's look at how we can describe a rotation. So remember, to describe a transformation, we must first state the type of transformation, and depending on the type, we state some additional details. So we see this here is not an enlargement. The shape did not get larger or smaller. It's not a translation because the orientation of the shape changed. And it's not a reflection because, you know, there's no mirror line here to show that this is reflected. So what this leaves us with is a rotation. So to describe a rotation, it's very easy to describe. We must first state the amount of degrees that the shape rotated and whether this degree was clockwise or anti-clockwise. And we must state the center of rotation. So a key tip, most times in CXC, the center of rotation will be the origin. So you can start off with the assumption that the center of rotation is about the origin. So you can, you know, start measuring from there. So let's describe this rotation. So we'll identify the center of rotation as the origin. So what we need to do, identify two corresponding points, well, the object and the image of a point. So here is the object E and here is the image E. So let's look at how the shape rotated from the object to the image. So we draw a line from the object and we go towards the center of rotation, which we identify to be the origin. And there's a way to find that I'll do in a subsequent video. So we draw a line from E and we go to the center of rotation. And then we draw a line from the center of rotation to the image. And then we measure the degree in which this rotation occurred. So we see we can measure this here. We don't even need a protractor. We see that this here is 90 degrees. Or we can consider it 270 degrees in the other direction. So what we have here, we have a rotation. So from the point E to E, from the point E to E prime, we see that we went in the clockwise direction. Because we know clockwise is like this. That's how the clock moves. 90 degrees. So we have 1, that the center of rotation is the origin. 2, it rotated 90 degrees. And 3, the direction is clockwise. So to describe this transformation, we will say the object NREQ undergoes a rotation of 90 degrees clockwise about the origin onto N prime, R prime, E prime, Q prime. And that is how we describe a rotation. We state the rotation, of course, is the transformation. We state the amount of degrees and the direction and the center of rotation. All right? So the beauty of this here, we just use 2 corresponding points. You can use the image of one point and the object of the other point, and that will give us it. If you use Q and Q, you will get the same thing. If you use R and R, you will get the same thing. You will get the same number of degrees and the same direction. If you use N and N prime, the same thing will occur. You will get the same number of degrees and the same direction. So you just need the object and image of one point. So let's go. Let's perform a rotation. Now we know to describe it. Let's see how we can perform a rotation. So it says A 1, -1, B 7, 0, and C 4, 4. Triangle ABC is mapped onto triangle A prime, B prime, and C prime under an anti-clockwise rotation of 90 degrees. It's anti-clockwise now. About O, so about the origin O. Illustrate on a clearly labeled diagram and state the coordinates of A prime, B prime, and C prime. So we want to perform a rotation about of this triangle ABC. So the first thing we need to do, of course, is draw the triangle. So I have the triangle ABC. So we see the point A was 1, -1. So we go 1 across -1, which is this point. And the point B was 7, 0. So we go 7 across and 0 up or down. And then C was 4, 4. So we go 4 across and 4 up. So here's C. And we want to rotate this shape 90 degrees anti-clockwise. So what we do, we take the first point, which is A, and we draw a line from A to the center of rotation, which is the origin. So we draw this line here. So that's what we did here. We draw that line A. And then we measure 90 degrees anti-clockwise. Remember, anti-clockwise would be in that direction. So we go 90 degrees anti-clockwise, and then we take our compass. Well, of course, we draw this line. Then we take our compass and we open it to the length of this line, and we scribe an arc to get the exact location. So we see the intersection happens here. So we see that is a rotation of A, and this is A prime. And of course, we repeat this for B. So we draw a line towards B, towards the center of rotation, and then we open 90 degrees anti-clockwise. So 90 degrees anti-clockwise will of course be here. And of course, this will take us, if we extend this, this will take us somewhere like that. So here would be B prime, and then we do the same thing for C prime. And this is what it will look like after we went through all of the points. So we see for C, we draw a line from C to the center, and then we open 90 degrees anti-clockwise, so 90 degrees here, and then we open our compass from the origin to C, and we scribe an arc all the way around here, and that will take us here. And then we extend here, and this will give us the point C prime. So it's just draw a line from the point to the origin, in this case the center of rotation, and then we just open the amount of degrees to the direction that we want, and we extend that line. And then we take our compass and we scribe to get the intersection. All right, and the question said, state the coordinates of A prime, B prime, and C prime. So let's state the coordinates of A prime. So the coordinates of A prime would be here. So this is 1, 1. So A prime would be 1, 1. B prime would be, so we see 7, we go 0 times across, 7 up, so 0, 7. Coordinates of C prime would be So we see C, we go negative 4 times across and positive 4 up. So negative 4, positive 4. And that will give us A prime, B prime, and C prime. And that is how we perform a rotation. That's how we describe a rotation. So of course, I must leave one for you to practice on your own or with a few. So find the coordinates of the vortices of each figure after the given transformation. So of course, we're looking at rotation. So you want to plot these points and then rotate each point 180 degrees above the origin, and then same thing, 90 degrees above the origin, 180 degrees above the origin, and 180 degrees above the origin. So the thing about it, 180, when it's 180, you don't need to state whether it's clockwise or anti-clockwise, because 180 clockwise would give you the same thing as 180 anti-clockwise. So to recap, to describe a rotation or to perform a rotation, we need 3 things. 1, we need a center of rotation. 2, we need the angle in which the shape will rotate. And 3, we need the direction, whether it's clockwise or anti-clockwise. So with that, this has brought me to the end, and I will see you in the next video. Take care.